All right, voltage regulators. Oh, I hate it when that happens. Voltage regulators. I don't know why I actually paused the video as if there's somebody else watching it out there besides you guys, because even you don't watch it. So.
I watched last night.
All right, the voltage output. Voltage.
Tim, you were here when it was made.
The voltage output of a generator is dependent on three things. What are those three things? Speed of the armature. I'm not done talking about that yet. All right, so I told you when flying the Cessna 140 at night, they had a little 20 amp or less generator, has a landing light and a taxi light on it, and the nav lights, and that's about it. And so it works just fine when you're flying along, and then you pull the power back to land, you go back to an idle, and what did I say happens? Generator just shuts off. It's just offline. It's the way it is. And that's the way they work. It was not broken. So, and the faster you spin it, the more the armature is cutting the lines of flux. Faster it's rotating, you have a greater change. And so you get more output. So it's dependent upon the speed. Type of windings. Not really. Well, kind of. We'll go with that. Number of armature windings. The more windings you have, the more efficient it's going to be, and the more we're going to cut. If we only had one loop, then you know what that looks like. We started with that, so we got to have number of armature windings. Nothing you can do to control that. It's just the way it is. It was an engineer figured it out and built it that way. And very good. Strength of the field. B. There are three different elements. To control. Four in a twin aircraft, or a twin engine, or multi-engine. I should say twin multi-engine aircraft.
What if there's 4 engines?
Huh?
What if there's 4 engines?
That's why I said multi. Multi means many.
Then there would be more than 4.
4 items. 4 items.
3 different elements. Like a cube.
There are 3 different elements to control. 4 in a multi-engine aircraft. So that you add another element. What are these elements?
I don't even know.
1, 2, 3, and 4.
Reverse current cutout.
Reverse current cutout. Reverse current cut out. Hey, you got number 3. Give me another one. Voltage. 3. Current. And I'll tell you the 4th. Equalizing. You can't have, in a multi-engine aircraft, you cannot have one generator that is outputting more than the others. Then the others just become more of a load. It doesn't share it. And so one does all the work. So you have to equalizes the current, the circuit. Huh? No, you actually have to parallel. You have to actually adjust it. All right. I'm gonna move this over. Nobody's yelling, so I guess it's okay.
Hey, can you go backward, please?
No, you're good.
You're good.
You're good.
Let's see. Where was I? Voltage regulator. Let's talk about the voltage regulator. Voltage.
That's true. Well, we're gonna talk about it again. What about the field winding?
That was voltage regulators. What about the field winding?
What about this fan?
Voltage regulator specifically. So the whole box is called a voltage regulator, but the whole box does a bunch of different things, right? It does voltage regulating, it does current regulating, it does. But now we're going to talk about inside of the box, the specific voltage regulator. Now there are a couple of different examples you're going to run across, but we're going to stick with the one that I'm going to use here, voltage regulators. Where am I here? There are basically 3 types of regulators. You've got solid state. That means it's all electronically controlled. We've got, going old school, carbon pile. And we got the vibrator type.
Dave knows all about
Man, look what you done. You driven him to drinking.
that. That's just your
Nope, it's those dang cookies over there that PK brought in that I like.
Well, that's why I brought him in, Kevin.
All right, the operating principle of all 3 types is to control the what?
Field winding.
Field strength. More field strength means more or less output.
More out.
More output. If you got too much output,
Reduce the field strength.
there you go. All right, let's talk about vibrator type. I think I have a picture here somewhere. Nope. Keep going. There we go. Simple voltage regulator. All right, so draw. Should be able to highlight it. There we go. Look at that. Okay. Take a look here. We have in a simple voltage regulator. Why is that like that? There we go. Okay. Armature, we have the field right here, yes? All right, that's what it shows. Okay, so we can figure this out. We got the load going this way. So armature comes off the armature, negative, and we're going to go through the field coils. And let me see. So if this is the, I'm going to draw it like this, generator. Generator on this particular one has 3 posts coming out, A plus, F plus, and A minus. Where's A minus going to be?
Ground.
What?
Ground.
Ground. So that's probably a ground. Probably doesn't really have an A minus, and it may not really come out that way. But I'm definitely going to have an A plus and an F plus. Now, there's 2 different type of generators. There's the A type and the B type. Have I talked about this? Okay, A type. In an A type, the field needs a
Ground.
field needs
Ground.
a ground. In the B type,
It's ground.
field needs a plus. battery or arm. Means it's already grounded. So what do I have here?
Say type.
Well, what is it getting? It's going to the load. So it looks like a B type. It's already grounded.
Yeah.
So it's grounded into the frame. So this would be more of a B type. So regardless of the type, but I want you to know that because a lot of this revolves around A or B type. In fact, shame to admit it, but I told you I worked in a shop and we overhauled a lot of engines, and we had a guy who overhauled a lot of generators. And working in tandem, I watched us buy a lot of voltage regulators because what would inevitably happen is I don't think that the person working on them quite understood the difference between an A and a B type. And so inevitably we would get the engine all put together, put the new generator on, fire up the engine, everything worked great except we have no volts and we have no output on the amps. So what does that mean? Why is that? So what's going on? No output. So I got no output from a freshly overhauled generator.
Field windings are grounded.
Well, inevitably somebody would say, we just need to flash the field. And inevitably somebody would go over and hook up a bunch of wires.
Oh, you need to remove the voltage regulator.
And then at that point I would pull off the voltage regulator and generator and send it out to have them both fixed. And inevitably the guy who would fix them would call me up and say, yeah, your generator's fine, but your voltage regulator was melted. What'd you guys do to it? Never mind. So I always made it a point to just have them fixed right to begin with. So what happens is, all right, so talk. Is the generator self-exciting?
Yes.
All right, what does that mean?
Like it has residual magnetism.
Holds residual magnetism.
Has residual magnetism. Well, one of the tests that you do, you're using that the growler with the 110 probes on the end. By the way, don't grab them and hold them real tight like it's a... Did you do that?
For like a minute.
Yeah, for a minute. You learn really quick. It's not a Simpson meter. They're 110 probes. You grab them and hang on to them, you will feel what 110 feels like. All right, it's a little bit of a danger
It
there.
will latch you on.
It's not too bad. I don't know.
It's all right.
It's not comfortable, but I've done it too.
Scare him the first time.
All right.
This is the one that was shocking himself for fun.
I know. So you're running 110 AC voltage through those field coils. What do you think that's going to do to the residual magnetism?
Increase it.
Nah, that tends to want to kill it. All right, so you can kill it or inadvertently go backwards. And so the theory is if you have a generator that was just freshly overhauled and you get nothing working out of it, well, number one, it means it wasn't tested, so it means it wasn't overhauled, so don't call it an overhaul, but I digress. But if you've killed off the residual magnetism and you go to run it, you're not going to get anything. So you have to do this thing called flash the field. Well, the directions for flashing the field are not terribly difficult, but the first thing it's going to say is if you have an A type, do this. If you have a B type, do this. So you can't just try it and go, well, I'm going to try this and see if it's an A type, then I'll try this and see, and it doesn't work that way. And that's how voltage regulators get bad. Yeah.
On the B type, what does that say in parentheses, bottom or?
Battery.
Battery.
This is a very fat pin. Battery or armature.
Okay.
All right, so which means this F needs some sort of battery or armature. Go back to my draw, get that out. So what's happening? Go away. So what's happening here is this one I'm saying is a B type because this is grounded over here. This is the negative side of everything. This is the positive. It's going to the load. So I haven't even got to the load yet. So this F is picking up A. Well, if I wanted to, well, I could certainly just take this and go, well, I know how to make this thing work. I'm just going to go from A to F. And will that energize my field? All right, so the armature produces power. Power comes up through here. You have current flowing this way. It picks it up here. Current flows through my field windings, comes down here. This is the negative side. Do I have field strength now? Will this work? Well, there I see blank stares.
For a minute?
Oh, it will work, but it will keep on going up.
There you go. It'll work. Is it regulated?
No.
Absolutely, completely unregulated. So what would the output as far as voltage be of this? Say it. All of it. You'll find out very quickly just how much it, and what it's going to do is it's going to heat up very rapidly. As it heats up, there's a lot of solder in the armature, and so we have solder that's heating up with an armature that's spinning. So we have centrifugal force, so then what happens?
Slinging.
Start slinging the solder out of it, all right? And then it's going to end up looking like the slinky that's shoved in here, right? That's not the armature, but
Can we do that?
make it go downstairs if you want to. All right, so this right here, what's that? Eraser.
Tried that? That'd be really cool.
All right, so you don't want that, but this is connected. I could connect that, and I'm going to get all the power out I want. So there's a question, it's like, well, how can you test the output of a generator? Well, you can jumper it for whatever it needs. This is a B type, it needs battery. So, but what it is doing, down. Nope, I should not move that down once I draw on it. All right, so what this is doing then is we have power is going to come up through here, and now it's going through rheostat. What's the rheostat doing?
It's a variable resistor.
The variable resistor that's doing what?
Simulating a load.
It's not simulating a load.
Just
It's controlling how much,
Goes to the load.
not to the load,
to the field.
how much is going through the field. So if I wanted to, this would work. I put a little dial on this, and what do I need?
A monkey.
Thank you. It's exactly what I wanted. A monkey. So I get a monkey, and, well, now you got to do a couple things. You got to provide the monkey with a voltmeter, so the monkey can watch the voltmeter, and terrible at drawing monkeys. So the monkey has the voltmeter. And
That's
Oh,
me.
would you be happy to
He's not getting all that.
And so all the monkey has to do is turn this thing, but he's got to be on it. The minute it goes, so if this is a 14 volt system and I want to set it 14 volts, monkey's going to have the dial right there. But as soon as I change the load, he's got to change it real quick. As soon as the battery charges up a little bit, got to change it a little bit quick. So the monkey's going to be very, very busy, right? And then I do not know exactly what you do with the bananas, but anyway, that's a whole other thing. So this would work, but it's not automatic. You got to have a monkey involved or a co-pilot. So whichever one. But that would
Same
work,
thing.
right? I don't need to go there. So do you follow what's happening with, and that is controlling the output as far as, what am I controlling?
Field current.
Okay, I'm controlling the field current to control what ultimately? What's the monkey watching? Hey, the monkey's watching volts. What about an ammeter? Does the monkey look at the ammeter? You can only watch one thing at a time. I need another monkey. So he's only watching volts. So what happens if he's standing there staring at the volts, and this is rated at 20 amps, let's say it's rated at 20 amps, and suddenly it's over here at 40 amps. Is the monkey able to control that?
No.
He can't, because he's over here watching volts. We need another monkey and something else going on. So what's going to happen to the generator? You're going to start losing solder in your joints. It's going to heat up, overheat. Okay, so take away from this slide that you must have the difference between an A type and a B type. You've got to get this down. All right, and also that this is only controlling voltage. Amps is going to, he's just going to keep dialing in voltage to keep it there. And if you keep adding loads, you'll eventually overheat the generator. So this is only going to work for one thing.
It's like a wheel test.
Yes.
Yes. All right.
Kevin, how do you know if it's an A or a B type?
One random.
Just by looking at it, you can't. That's the problem. You have to understand the system. All right, let's move this down a little
Kevin,
bit.
do we have any like B type in our?
B type? I don't know. All right, so this is more representative of what you have in an aircraft. All right, so we've gotten rid of the monkey and we put in contact points that are adjustable. And let me go up here. Get my highlighter. All right, so we've got we've got the generator, the armature, A plus and F plus. We'll assume that it's grounded internally, so the A is internally grounded. Is this an A type or a B type?
B-type.
B type. It's a B type because the field needs what?
Battery or
Fuse need
Does the field need is it looking for a positive or is it looking for a ground? Okay, it's looking for a positive. Am I going to find a positive? Can I find a way around through the points up? And there's a positive right there. So there's a path right through here. So it needs a positive, which means this. Oops, where's that one? This is just grounded. Oh, it's a better pen. All right, this is grounded inside. So there you go. I could turn this around and make it an A type grounding. Instead of coming back to the F, this would just go off to ground. All right, I have to do some other things here. But anyway, okay, so it's looking for that right there. So how is this working then? Let's see. I have no idea. What does this pen do? It's a crayon. All right. So to control the generator, we have to control the field. So we have, well, that's just pretty.
You got rainbows in there?
I do. It's like a rainbow pen. All right. So we have. I know.
That is full of hopes and dreams, right?
All right. So it's coming back over to here to ground. I can't do that. I just can't.
That's the generator fluid, right?
Hopes and dreams.
Rainbow smoke cake.
All right.
Oh, man.
I know. Ruined it
All
all.
my hopes and
Kevin, could you just hit the back button, just take off your one little right?
I don't know. I'm thinking of something else here. Okay. So let's go.
What do you think about that?
I should think which pin I should use and how I can adjust it. And I do have different colors and thicknesses. Well, look at that. See? Life is great. That's what I was thinking about. All right. Okay. So this one is just a little bit different than what I was thinking, but it doesn't matter. So when the points are, let's talk about what happens when the points are open and the points are closed. So when the points are, that has got to be a connection. So we have current coming through here, going to ground, which is going to be the sensing loop. So when the voltage gets too high, it's going to sense it in this loop right here. And when it senses in this loop, says, okay, wait a minute, this is the monkey's job before, but now it's not the monkey's job. Voltage is getting too high. What's it going to do?
Closing the
Well, now that I've learned how to do this, I'm just going to go green over here. All right, so it's going to pull on this and open the points. So normally the points, we'll say normally they're closed. They are normally closed, actually. So normally closed. So power is coming through here, and it's coming up in here, and it is energizing this. So right now, when these are closed, I've got voltage here, I've got it coming through here, and I've got it going through here. So let's just say they're closed. They're stuck closed for whatever reason. And not a bad scenario. So we started up. When we started up, these are closed, right? And the generator's turning kind of slow. And it's not really, and we want 14 volts out of it. It's not producing 14 volts. So there's not enough power here in this coil to open these up. So what's going to happen? Well, the field is going to get all of the available output of the generator, which isn't enough. And that's going to be a problem for a third monkey. But right now, it's not enough. So we increase the RPM, the engine starts to speed up. Wham, I suddenly get to 14 volts, and this is going to open up right here. And yes, I can just hit back. And what happened there?
It goes through resistance.
Okay, so it goes to the resistor.
Resistor, right?
So the only way around, so it significantly decreases, so it's going to come around through here, because we hit what we wanted, and is going to significantly decrease the field strength. if I significantly decrease the field strength, what's going to happen to the output of the generator?
Significantly decreased.
Okay, so it decreased a whole bunch. Well, when it decreased, what happened to the field strength here? It decreased, so the points just happen to close. Bam, they close. So now they're closed, and it comes back this way and gives full field strength. Well, now that it has full field strength, what's going to happen? Oh, it builds up too much, and so the point's open. And then the current has to flow this way.
Monkey's out of a job.
And now that I've significantly decreased the resistance here, or significantly increased the amount of current flowing through, what happened to the output of the generator? Oh, it decreased way too much. So what happens? Well, now the points close again. And so that's why the points are constantly, they're vibrating very fast and rapidly. And so we could, if we wanted to, because of the monkey union,
The Banana Republic.
the Banana Republic, the monkey could just take a wire and connect it from the A, because this is a B type, and the field needs a what?
Positive.
Positive. Okay, so right here I have the generator output. Oh, Tim, come on.
Let's go. We need a monkey.
Come on. Kevin, what's this I hear about you calling your students monkeys? Don't drop the bottom out. You have to hold it up really high so you can see it over the top of the screen like this. Okay, so we have an A, which is armature output, and F. The field needs a what?
Positive.
Positive. So we could just get a monkey to take a wire from the field and just touch it just vibrate it across the armature nonstop at a proper rate, and we would get
That's the idea.
yes. Now, yeah, you can put it down.
Then we need a smart monkey.
You need a smart, highly trained monkey.
I guess I'm out of the job.
All right, but that is what's happening here, and that's what's happening with the voltage regulator. Now, a couple things. This winding right here. Why not? This winding right here. This winding right here. Is it wired in series or in parallel with anything?
Wired in color.
It's living color. It is
Must be
In series.
parallel. It's hard. It's fat. It's hard. P-A-R.
Change the thickness.
Oh yeah, I probably could. Well, let's waste some more time with that. Yeah. Well, then I don't think you'd appreciate the colorness of it. See, it's just getting... Okay, so this is wound in parallel. So is this wire going to be kind of fat or pretty small? Okay, that's going to be a very small wire. And that's how you can identify when you open up a voltage regulator that the wire is very, very tiny. And it looks like if you would touch it, it would break. But I know it won't because you guys won't stop freaking touching it. So I love that. I have yet to have a student who can talk about a voltage regulator without constantly pushing on the little things that open on the contact points. Let's see if you can be the first. All right, so it's a very small wire, so it's in parallel. You should be able to identify it as being in parallel. If it's in parallel, then it's sensing what? And that kind of goes back to, oh, this is just too kind of fun. If it's in parallel, it's sensing what?
No way. No, that's-
What's the matter?
Wow.
What happened here?
How do you plug in a voltmeter parallel with the thingy?
It's going to be sensing rainbow voltage. This is just obnoxious. But it's voltage. Everything in parallel is going to match in voltage. Is it going to match in amperage?
No.
Okay, so right there, that's how we know. It's in parallel, it's small, it's voltage. Is this voltmeter sharing the load with this over here? Please say no. I'm just going to tell you it's no. The answer is no. Okay.
You said yes.
All right.
Brother, Tim.
All right, so I don't want to spend, I got to get rid of that pen. That's just too much.
What kind of system is the vibrator?
What kind of system is it?
Yeah, or like what would be the application?
To control voltage output.
I know, but aircraft.
Yes, aircraft.
Okay.
Yes, definitely.
We talk about aircraft.
And old cars. All right. Brand new aircraft and old cars. There we go.
New aircraft, huh?
Yeah. All right. A carbon stack. I don't know if I want to go into this one too much. It's really the same thing. So this is a carbon pile. We have the generator. Again, this is the field at A. Field wants a battery, or is it picking up ground?
A. But
It's a B type, thank you. Is it too small or something? All right, so the thing with this one, instead of using a vibrator coil or vibrator points, there's carbon discs in here. And the tighter you squeeze them, the less the resistance. And the more they pull apart, the greater the resistance. So you can just control the resistance going to the field through this coil over here. This allows you to do an adjustment, so you can dial it in, correct? But what happens is we've got, now is this in series or parallel? Okay, so it's running series up through here and going this way. I want green. I want to give you green. There we go. All right, so through this way, we're in parallel, going to an equalizer bus, which means there's got to be another generator. So that's an equalizing circuit. If you have two generators, you have to parallel the generators. That's the word I wanted. So anyway, as this comes through, it's going to create an electromagnetic field. As the voltage increases, and we need to add resistance, it is going to pull the stack apart, adding resistance. As the voltage decreases, the stack will come back together. I said that backwards.
No.
Did I say it right? Okay. As the voltage increases, I've got to add resistance. So yes, it'll pull it apart, increasing the resistance, which will then kill off some of the current going to the field coils here, which decreases the generator, decreases this, lets the stack relax, and
it's a vibrator too.
okay, so does it? I don't really think it's not going to vibrate at the same rate. It's certainly going to adjust, but I could see where it could really kind of almost find a spot and be kind of happy there. Just move a little bit back and forth at one particular spot.
The movement does that actually see?
There,
Like, is it, can you even notice it?
there's not something that's open to look at. I don't think so. All right, equalizing circuit. That'll just okay. So let's go back to this, and let's go back to this, and all right. We'll some notes on this. I feel the same way. All right, vibrator type. All right, so we have a. How much do I want to write here? Oh my goodness.
Apparently a lot.
A resistor.
Thank you.
A resistor is intermittently cut in and out. Cut in and out of the field circuit. I'm going to scroll up here so I have more room to write. The resistor is intermittently cut in and out of the field circuit by normally closed breaker points. What does normally closed mean? Does that mean that they are in fact normally closed? Like the more you look at it, take an average.
The more you poke it.
The average of the time it's running, they're spent more time closed than open. What does normally closed
They
mean?
start closed.
They start closed. Their relaxed position with nothing happening means that they are closed. It takes some sort of external influence to open them. So they start in the closed position. So if I go up to an aircraft that's completely turned off, shut down, battery off, the points are going to be closed. Okay. So normally closed breaker points in series with the field. Let's see. Points and resistor are parallel with each other, but in series with the field. Yeah. Okay. 2. Voltage coil is connected in parallel with generator output, so voltage coil. We could call it a voltage sensing coil if we want. Voltage, we'll do that, sensing. Sensing coil is connected in parallel with generator output. Gen output. So since it's connected in parallel, it means, again, the wire is very thin. Okay. As the voltage of the generator increases to the desired value. Now, what should the value be of a generator? 14 or 28. As voltage increases to the desired value, the coil opens. The coil opens the points, or the electromagnetic field that is created by the coil opens the points. And current to the resistor, current to the field, that's what I want to say, field must go through a resistor. Okay to roll up a little bit there? I'll just go till somebody screams.
Don't do it.
This drops the field current and lowers magnetic strength. And lowers magnetic strength of the field and generator, I don't want to say output, generator voltage drops. There we go. All right, so I opened up the points. I had to run now the current that's going to the field coils through resistor. So now the field strength diminished. So what did that do to the generator output voltage? Decreased it probably quite a bit, way below 14. So what happens? Got to close points then. So as magnetic strength, as magnetic, I said magnetic field drops. How about that? Field drops. So does output. So does generator output. And coil, voltage coil, releases the points, which removes the resistor, which removes the resistor. And we're back to full speed again. So, and they just vibrate between those 2 points. Points open.
Is that efficient?
You say you're going fishing?
No, is it
I
efficient?
just want to let you know, Kevin.
I feel like it wouldn't be very efficient because of the opening, closing so often.
Been doing it for 50, 60 years that way or more. Oh, I would suppose, well, number one, I don't think it's an efficiency problem. I think it's more of it's a moving part problem.
Yeah.
So points burn and arc and wear out. So if you go with something that's solid state, you don't have this problem. So points open and close many times per second. Many times per second. I'll just run through this. The carbon pile. Carbon pile. I talked about the carbon pile. I don't want to spend another 20 minutes writing notes on that one. Because I don't have time. All right, equalizing circuit. What's an equalizing circuit do?
Balances out the
Where am I going to find an equalizing circuit? What kind of aircraft?
multi.
All right, in a multi-engine. So in a multi-engine aircraft, and I said this already. If the generators are not, what's it called? Paralleled. G-N-E. If the generators are not paralleled, and paralleling a generator, that's something you do as a mechanic. So whenever you change out a generator or a voltage regulator or any of the charging components on a twin-engine aircraft, you've got to go parallel them, which you're going to follow the manual. You're going to run up the engines to a certain RPM, matching RPM, and you're going to fine-tune and adjust the voltage regulators to a point, and there's usually an equalizing circuit built into the middle that takes out and fine-tunes it even further kind of on its own, like a third voltage regulator. And if you don't, you're going to run into problems. So if they're not paralleled, one generator will do all the work.
Do you have to do this like pre-flight, or is this like?
It's a maintenance issue.
It's a maintenance.
Yeah. One generator will do all the work. So, and you should be able to somewhat instinctively figure that out by now. If you have a generator and they're both going up to a bus bar, and this one's putting out 14 volts and this one's putting out 13, then this one is more negative than this one, and this one's the positive one, and so it's going to be flowing. It's not like this one provides 13 and that one's 14. It doesn't work that way. You got this one over here is negative compared to this one, so it doesn't work. So yeah, well then you'd have the reverse current cutout should open up and take it offline. So it doesn't do any good. Just so you need to parallel them. So that's kind of a I've got this equalizing circuit, and I showed it to you a minute ago. I've learned through experience that going over it is really a frustrating thing for you, and I don't believe I ask any questions on how it works, so there's no point in wasting a bunch of time. So, given that, I think we will just, since it's 9:18, leave it right there. And Tim, you don't have to go to the gym tonight since you did your arms.